I started out in my career mostly as a designer, so I would find some problem I wanted to work on and begin to make prototypes and draft patents and do technology development and product development. And I did work in upper limb prosthetics. I did work on manufacturing systems and actually a pretty broad range of things. And then as I began to pursue a PhD, I thought it'd be interesting to abstract a little bit away from that and ask, what can I learn about how to design as opposed to being a practicing designer? And there, I became really interested in the question of how experiments are used by designers. You know, I have an idea and I evaluate it. And then I make a change to that, thinking that it'll become better, and then I evaluate that. And I am now part of a process of adaptive experimentation. I'm making changes in an effort to gain certain benefits, and then I'm learning from that process. In some cases, I realize something that I'm trying is not working, and I back up and try something else. And yeah, I got interested in this field of design of experiments. And in design of experiments, you know, one of the things that people learned over time is that if you plan ahead, you can gain information more efficiently. And so in areas like agriculture, people plan big sets of experiments in order to gain those benefits. And they're very highly parallel in nature, especially in agriculture, where you know you make a decision and then you don't gain data until the end of the growing season. So parallelization is very important there. In engineering, most of the ways that I experience engineering, you can gain information much more quickly. So in the morning, I can have an idea about what I'd like to change. By the afternoon, I might have some results that tell me whether it's a promising path. So it's very natural for engineers to want to experiment more adaptively this way instead of planning way ahead. And so having some kind of bias toward that, I began to explore it more systematically to ask under what conditions that adaptive style of experimentation might actually be better than the process that grew up in agriculture, of planning way ahead. And it turned out we could establish that if the experimental error wasn't too high, you know, you had good instrumentation and carefully controlled experiments, and if you were able to adapt in each step, and if the interactions among the factors that you were exploring with weren't too small, then actually the way that engineers tend to naturally experiment turns out to be statistically superior also. And so those results caught some attention because they were counterintuitive. You know, I work with a lot of different groups that are developing interventions. So for example, I'm working with a group right now that is interested in the question of how to offer surgery in austere settings. So there are many settings where there's just not an operating room available, but you might be able to bring a well-trained doctor into the situation, or maybe there already is a well-trained physician in the location, but there isn't a way to prevent surgical site infection, which would often have a high incidence if you couldn't maintain very sterile conditions. So we've been working on this idea of keeping just a small region around the operating site highly sterile to build kind of a tent locally that's clear so that the surgeon can see what they're doing, that has some kind of access like sleeves so that you can get in there and do the cutting and suturing that you need to do, and that can handle the air. So, you know, you keep the things out that obviously need to be kept out, like flies, right? So we've been working on this thing, we call it Surgibox, and we've got a lot of things that we need to figure out, like which particular formulation of plastic would be best, and how to best make the seams. And should it have a frame, or should you just rely on pressure to keep the plastic up? And we're trying to work through all those things and work with our partners at Mass General Hospital across the river here, and try to make a product that's practical, that you can get through the regulatory process, and that we can scale at a reasonable cost.